Okay, we have this quiz problem. Graph this without using intercepts and solve the system of equations by substitution. This first one. We're going to find a point on the graph. Okay, let's say pick a number for x. Now let's see. What is going to be pretty high? Of course, we know the y-intercept is going to be up to 20. But let's let x equal -12. So I could use any value of x. I just consider -12 would be a good choice. If x is -12, half of that's -6, add that to 20, you get 14. So we get the point -12, 14. So I'm going to draw a couple of horizontal lines, or a couple of dotted lines. Okay, so x equals -12 here, y equals 14 here. Now, the slope of this line is 1/2. Okay, so I can start from this point. This point's on the graph. And I can choose, no, I know the slope is 1/2. So I can choose any run and figure out what the rise ought to be. Okay, so let the run equal what? Well, the slope is 1/2. I don't have equal scales here. Matter of fact, maybe I ought to make the scales look kind of equal. We're going to get a more intuitive picture out of that. We do. What I mean by that is, if x is 12, that's about this big. Okay, if y was 12, it would be about here. Actually, kind of almost looks like I have y equals 14 at about the right place. Let's see there. Yeah. Put it just a little bit lower. Here's our intersection point. So now if we take any run, let's say we take a run this far, okay? Then we should have a rise that's about half as much as the run. Okay, so if this is the run, this big, the rise ought to be about this big. The rise ought to be about half of the run. And I usually draw the run and the rise from the point. I chose not to do that, probably no good reason. Okay, so the rise might look about like this. So this would be our graph. So the graph ought to go through these points. Well, give me a number that corresponds to this run, according to the picture of this graph. Like, what would a reasonable estimate of the run be? Hang on a minute. Okay, so if the run, ask for an estimate of the run, I got 13. Now, actually, if this is 12, it's probably a little more than 2 here. If this is 12, 13 would be pretty small. So let's see how many of these it takes. It takes about 1, 2, 3, 4 of these to make up a run of 12. That's about 1/4 of this distance. So I'm going to say the run is about 15. Okay, just because it'll work out a little better. Now 13 wasn't a bad estimate. Could have used that. It still illustrate what we want to do, but okay, so the run's about 15. So then the rise ought to be about 7.5. So if the rise is 7.5 and the run is 15, well, I know that fits our slope. If we start from this point and run 15, so that'll take us out to where x equals 3. And from y equals 14 up to this point, this line should probably be about y equals 21.5. If I add 7.5 to 14, I get 21.5. Okay, so the point is, if I have the equation of the line, I can always find a point on the line. Okay. If I solve for y, I can always find the slope. And then I can always pick any run I want and multiply that by the slope, and I get the rise. So it allows me to determine another point. Another way of doing this is to say, okay, let's do this thing again. Okay, again, I'll use x equals -12 and y equals 14. The graph gets pretty high over here. I'm going to want to look at it over here. So I'm going to move over. This is x equals -12. I'm going to move over to x equals -24, twice as far from the x-axis. Now the slope is going to be 1/2. So the graph might look something like this. And I want to find this point. The slope of the line is 1/2. At x equals 12, we got y equals 14. X equals -12. Y equals 14. And this point would be 24 question mark. And well, two ways we can get this. We know that the run from -24 to -12 is +12. So the rise is 1/2 of 12 or 6. Well, if the rise from here to here is 6, then the distance between this line and this line is 6. So this line is y equals 6. And we can fill in the x coordinate 44, 6. Still another way. Never mind, I'm not going to do that. It would work, but it's not what we would usually do. I don't want to confuse you with something. You would usually do. Okay. Well, there it is. Now, everybody did well on this problem by substitution. We'll solve the first equation for y, and we'll number these equations 1 and 2. You got 2y equals 4x plus 6. You divide both sides by 2. And you get y equals 2x plus 3. And you plug that result into the second equation. So we take this, plug it in here, and out pops the equation 4 times y, but y is 2x plus 3. Okay, so we multiply 4 times the 2x plus 3 equals 4x plus 6. And now we know how to solve this equation. Everybody did this correctly. So 3 dots. The solution is x equals we're going to get 8x here, we've got 4x here, so we're going to get 4x on this side. That was not working out because I wrote down the incorrect right-hand side. I wrote this right-hand side, and I had that 4x plus 6 in my eye, and I wasn't being careful. We should get 4x, so 4 times y, which is 4 times this expression, and then it's plus 2x. Equals 12. And then we solve the equation and we get x equals 0. Okay, because this gives us 8x plus 12 plus 2x, which is 10x plus 12. We subtract 12 from both sides, we get 0. And of course, if you do these solutions, that's exactly what you're going to get. Okay. So y is going to be 2x plus 3, 2 times 0 plus 3, that's going to be 3. And then we plug in 0, 3. If x equals 0, this is going to give us 0, so we're going to get 2y equals 6. If y equals 3, 2 times 3 is 6, we get 6 equals 6. If we plug in x equals 0 here, we get 4y equals 12. Then y equals 3 gives us 4 times 3 equals 12, 12 equals 12. I don't have room to do the check, but I emphasize that you want to plug your solutions back into your original equations and make sure they work. Otherwise, you're kind of working blind, and you don't get immediate feedback if you make a mistake. Of course, you're doing this with open math, you'll get feedback pretty quickly, and that's good. If you're working on your own, you always want to do your checks when that's feasible. Okay. Well, it appears that everybody, at least everybody that's here right now, is pretty good with substitution. Um, and let me check one thing about people who might not be here. You know, how many times do I have to hit the poll? Okay, now we're gonna solve a system by elimination. Here's another system. Now we could solve both sides. We could solve one equation for y, plug into the other one, and we get a solution. We could graph the two equations and we get an approximate solution. What I want to do this time is, this is equation 1, this is equation 2. I want to do equation 1 plus equation 2. So what do I get if I add the left-hand sides together and add the right-hand sides together? Okay, now everybody's on track when I look and move along pretty well. Okay, if I add the left side to the right side, then I'm going to add 5x plus 3y to 7x minus 3y. We know then if I add this plus this, we can group our x's and we're going to end up with 12x. So we can just kind of look at the column. We keep the x's and y's in columns, then we know we can do this because we were going to do a very similar thing if we wrote out the sum of these two sides. And then 3y negative 3y gives us 0. That equals 36. So x equals 3. We divide both sides by 12. We get x equals 3. Then we plug that in to one of the equations. I'll plug it into the first one. Then we come down here and we have 5 times 3 plus 3y equals 15. And what goes in here instead of x is our 3. So we get 15 plus 3y equals 15. Which gives us 3y equals 0, so y equals 0. Okay, so there we have it. And then we check. If we plug in 0 for y, we get 5 times 3 equals 15. Plug in 0 for y here, we get 7 times 3 equals 21. Both of those check out. Briefly, we can also do a check of reasonability by sketching graphs of these two functions. And so we find that the intercepts are 5, 0, and 0, 3. So we have intercepts here and here. We don't mark the point here. And 0.35 is not on either graph. But when you cross these lines, sometimes tempting to do that. I think it's the first time I've ever done that, but I've seen people do it. Not gonna blame that with me. So we get a line out here, and then we get the intercepts of this graph, and that's gonna be at x equals 7. Sorry, x equals 3, and y equals -7. Somehow that doesn't seem to work. So we're gonna have something to reconcile. Here's x equals 3, and y equals -7, way down here. So we're gonna get a point here and a point here. Well, that's all good, but I did something else ignorant. The y-intercept of this graph is not at x equals 5. I divided 5 into 15 and got 5, and that was wrong. If I graph it correctly, 0.030 is the x-intercept for both graphs, and they cross there. Anyhow, you sketch and do it correctly. If you sketch a graph, it shows the intercepts, and then estimate the point. Right now, we can see we know exactly what the point was, but that usually won't happen. We estimate the coordinates of this point and see if they come out reasonably close to our solutions. And that could confirm our solution, just like plugging back into the equation could confirm our solution. And if it's critical to get this problem, then we probably do all three. Solve it by elimination. Plug the numbers in, check it, graph it, see if that works, or even solve by substitution. Okay, solve it 3 or 4 separate different ways. We get the same thing, then we're pretty sure we got it right. Okay, well, that was fairly straightforward, and nobody had any trouble with it, which is great. Let's look at one that okay. Here it doesn't come out quite as conveniently. If we just add both sides, they don't add, the one of the variables, neither of the variables will go away. If we add both sides, we end up with a 6x and a -y. So that isn't going to be very helpful. But what could we do? Well, just to illustrate, I'll tell you what to do. And then next time I'll ask you to figure out what to do. I want you to write out 2 more equations, where equation 1 matches equation 1, okay? And the second equation now would be where we multiply -2 by both sides of equation 2. So do that and go ahead and see if you can work out at least a few more steps of the solution. Now, I probably should have given a little more instruction on how to do this. What I want to do is write equation 1 here and write -2 times equation 2 here. And we don't want anything else underneath here. We want to leave space blank under here so we can proceed with the solution in a way that we'll discover. So if next to this 1, I write equation 1. And then write -2 times equation 2. Now, you probably don't need to do a separate calculation to do -2 times equation 2, but let's just do this. -2 times equation 2 is -2 times 2x minus 4y equals -2 times -12, which gives us -4x plus 8y equals 24. Okay, now I've written this out to the side. Again, this is important. I don't want to clutter up the space under here. I want columns where we're going to line up equal signs and do all that, at least for a while. So we do this calculation off to the side, and then we write this resulting equation here. Now, what we're going to do is we're going to add equation 1 to equation 2. And this is also very important, where equation 1 now refers back to the first equation in the last step. Equation 2 refers back to the second equation in the last step. So equation 1 is no longer this one. Actually, it still is, but equation 2 is no longer this one. Equation 2 is this equation. So here's the equation 1 that I'm going to use. Here's the equation 2 that I'm going to use. Okay, now having done that, well, when doing that, clearly the 4x and -4x gives you 0. So we don't even bother writing down the 0. We're going to get 11y equals 42. So y equals 42 over 11. Now, unlike before, we don't get a nice integer. We have a fraction to deal with. But that's what typically happens. So we take this and plug it in to one of these two equations. Now, if there's an equation that had an 11 in front of y, we'd use that because it would multiply out this 11. If there's some way to, if the coefficient of y in one of these equations had a factor in common with 11, then we could use that equation. Otherwise, as in this case, 11's prime, the only way you'd have a common factor would have, we'd have an 11 in one of these, or multiple of 11. Okay, well, so the first equation would give us 4x plus 3 times y equals 18. Of course, y is 42 over 11. That comes out 4x plus 126 over 11 equals 18. And we could put 18 and 126 over 11, use common denominator, okay? But when you have an equation, you don't ever need to use, you don't ever need to put anything over a common denominator. You just multiply by a common denominator. And in this case, we're going to multiply by 11. And we get 44x plus 126 equals 198. So that we're going to subtract 126 on both sides. We're gonna get 172 here, and we're gonna get 44 here. And well, 172 is divisible by 4, so it's 44. So we're gonna get 43 over 11. Now it's a bit of a pain, plug these back into the equations. It's probably safe just to plug these numbers back into one equation. You can also do a quick graph and see if these numbers make sense. And also, both of these numbers are pretty close to 4. So something's wrong because that's not going to get us anywhere close. We'd have like 18 plus 12, 18, and 8 minus 16 equals minus 12. So there might be an error in here somewhere. So I might want to check that. Now, everybody got 11y equals 42. So clearly going to get y equals 42 over 11. And if we multiply 3 plus 42, we get 126, yeah. 11 times 4, 11 times 18, those are right. It's 126. I subtracted 26, not 126. So we get 72 over 44, which is 18 over 11. And you should understand what I just did. I got numbers pretty close to 4 for both x and y. So if I was to plug 4 in for x and y in both of these equations, I should get something that's pretty much equal on both sides, and I didn't. I didn't have to write that out to see that that was terribly wrong. So I had to check everything and realized that I got busy subtracting 26 from 98 and just wrote down the 1 without really thinking and visualizing my numbers. Okay, so I've got like 18 over 11. Now x is close to 2, y is close to 4. If x is 2 and y is 4, we get 8 plus 12, which would be 20, but x and y are both a little bit less than 4 or 2, respectively. So 20 equals 20 is not bad. And then if x is 4 and y is 2, we get 8. Sorry, x is 2 and y is 4. We get 4 minus 16, which is negative 12. So these numbers are pretty close. So I just kind of round these numbers off to the nearest integer and check if I'm pressed for time. Okay, and I see that the result is pretty close, so I think that these results are pretty good. Okay. So sometimes you can check that way, just to make sure your solution is plausible, and you kind of at least want to do that most of the time. You know, here's one. Okay. Now, in order to solve this, there's no number that I can multiply just one equation by and get coefficients for one variable and another that are equal and opposite. So what I'm going to have to do is I'm going to have to multiply the first equation by some number. And the second equation by some number is probably going to be different. So that when I add them, one of the variables is going to go away. Now, it doesn't make a lot of difference which variable you choose to eliminate, because that's what we're doing. We're eliminating a variable. I chose the -2 for the first equation because that's what eliminated x. Okay. I want to choose two numbers here that will, when we multiply both sides of the equation, eliminate one of the variables. Now, just with a thumbs up or thumbs down, choose x or y. Doesn't make a lot of difference. So x. What numbers could you use here and here by multiplication? What numbers could you multiply by 3x and then by 4x so that you would get equal and opposite numbers here, equal and opposite coefficients? Like what multiple of 3 equals what multiple of 4? Let me say it a little more clearly. I want two numbers. If I multiply the first number by 3, I get the same thing I would get if I multiplied the second number by 4. Okay. Some people had a little trouble understanding the question, but I want some number times 3 equal some other number times 4. And you give me two numbers to put in for these question marks, they'll give us the same result. For example, you've got an idea? Hang on. Okay, so when I wrote it this one, people got it pretty quickly. Said, well, you can do 4 times 3 equals 3 times 4. And it's clearly saying you're going to get 12 either way. Okay. So you can always do that. You can always multiply one equation by the other number. You can always multiply one equation by the coefficient of x from the second equation, and then second equation by the coefficient of x from the first equation, and you get the same number. Now, what we're going to do here, though, is we're going to do, okay, we're going to do 4 times the first equation and -3 times the second equation, and we'll use the negative so that when we add them, the x's will go away. So go ahead and write that out. Be sure to follow the format. Remember, you don't want to do a bunch of calculations below here. Do it off someplace close by, but not in the column underneath, because you're going to have to fill this in. Okay. So that was good. Now I'll just illustrate. I'll carve out a little space here to do my scratching in, because I don't want to, I want everything to line up in columns. Okay, so I do 4 times 3x minus 5y equals 4 times 30, and I get 12x minus 20y equals 120. So I get 12x minus 120 minus 20y equals 120. Then I do minus 3 times 4x plus 3y equals -3 times 24, and I get -12x minus 9y equals -72. So when I add these, I get -29y equals -48. Now let's make sure I did that right. I think so. I'm not sure that agrees with the work I saw, but the work I saw on most papers, did this nicely, did the scratching out to the one side or another, and then kept these columns lined up. So again, 4 times 3 is 12, 4 times -5 is -20, 4 times 30 is 120, -3 times 4 is -12, -3 times 3 is -9, -3 times 24 is -72. So I get y equals 48 over 29. 29 is a prime number. It has no divisors other than itself and 1. So there's not going to be any common divisor here and here. So we're stuck with this fraction. Plug this fraction back into one of the equations. And I'll just go ahead and use the first equation, which then gives me 3x minus 5 times y equals 30. And y is going to be 48 over 29. That's going to give us 3x minus 190, 240 over 29 equals 30. Multiply both sides by 29. And the number is going to be kind of ugly. 29 times 3x is 87x minus 240 equals 870. So we get 87x equals 870 plus 240, which is 1110. And x equals 1110 over 87. Now, 1110 turns out to be divisible by 3, and so is 87. Divide by 3, you're going to get 29 here. And divide 1110 by 3, you're going to get 400 less 30, which is 370, I think. And multiply 370 by 3, I get 1110. And that's not going to reduce anymore because 29 is prime. Okay, this is pretty close to 12, maybe 13. And this is about, well, it's a little bit close to 2, not all that close. But if x is 13 and y is 2, 13 times 3 is 39, minus 5 times 2 is minus 10. 39 minus 10 is 29. We get 29 equals 30. So this checks out pretty well. And then 4 times 13, and that doesn't work. So apparently there's another mistake. And the mistake is here. Or I got a minus 48, it should have been a plus 48, so this should have been a minus 48. So this should have been a minus. This should have been a plus. This should have been a plus. This should have been a plus. So we would have ended up with 87x equals 630. We have 630 over 87, which is 210 over 29. So now y is about 7 and x is kind of close to -2. So y is pretty close to -2 and x is pretty close to 7. And that would give us 31 equals 30 up here. And 28 and -6 would be 22 up here. So that approximating this by -2 and 13 gives me pretty good agreement up here. So now I have some confidence in my solution. Okay. Once more, emphasizing the importance of checking. I apparently woke up pretty careless this morning, writing down negative signs when they shouldn't be. And occasionally, wrong side of one equation when I should be writing another. And it just occurs to me that equally careless by having most of this problem off the screen. So let's just go over it again real quickly. No, I've got them. Well, never mind, there's no excuse. Okay, here's my system of equations. We figured out that if I multiply 3 by 4, I get the same thing as I multiply 4 by 3. So I just take these two numbers and multiply each one by the other, and I get the same thing, obviously. Okay. Now, if I multiply the first by 4 and the second by -3, I get these two equations, and we can check that out. I wrote that down over here. So that our coefficients of x are equal and opposite. Now, when I add the two equations, it's down here, I'd say we're down to equation 1 plus equation 2. Equation 1 referring back to this first equation, equation 2 back to this one, I get this. I made a mistake when I wrote this down. I wrote down -48 when I should have written down 48. I picked up that minus sign and I didn't look back to see that I'd done it correctly or to find that I'd done it incorrectly. So be more careful than I'm being. Okay, so anyhow, we get this and we get our solution for y. It's very straightforward. Then we plug this solution into this equation and we get this. We multiply the -5 by the -48 to get a plus 240 over 29 here. Then we multiply both sides by 29 to clear the denominators. And we get this equation, which we easily solve, and we get this. Then I said, well, if this was 210 over 30, I'd have 7. So I'm saying that x is pretty close to 7. And y is, it's a little short of 2. It's like probably 1.7, -1.7. But we're going to just approximate x as 7 and y as -2. And we plug those numbers back into the equation. If y is -2, we get a plus 10 here. X is 7, we get 21. 27 and 10 is 31. So we have 31 equals 30. That's pretty good agreement. Then, if we plug in the same numbers, 7 for x gives us 28 here. And -2 for y gives us a -6 here. And 28 minus 6 is 22. We get 22 equals 24. That's pretty close. If we took the time to plug in both fractions, then it's very plausible that they're going to work. Since we came out close just by approximating these numbers, chances are we didn't make a mistake. Now, originally I made a mistake and I got something ridiculous. Since I made this negative, I got a positive here. And I got a different number down here, 13. And I plugged them in and they worked fine in the first equation. I was feeling pretty good. Plugged them into the second equation, it was nowhere close. So I had to go back and find my error. Okay, again, this is why we check.